Oh my god. Wait, Dynam at one.
Salud. Was working on the warm up now.
Yeah. I did. The one that we read.
Seven, five.
Oh, I didn't know.
So this could be, no?
I think so.
Number two.
And then like the one.
Yeah. Max, you get
Oh,
Twitter. It's like a little, yeah.
Negative five, like this, but do I have?
Yeah.
to-
Oh, wait, number one.
How did you even do this? This is good.
Negative one. One of those.
Two, one, right? Zero, zero.
How do you?
What is?
Isn't that-
I'm done with that.
It could be like a like one of the negative,
Yeah.
like quadrant three or
Yeah,
whatever.
he's 3 or 4 guys.
Negative.
Well, this is what I got wrong.
Five.
Do you remember?
I have three, four,
Yeah.
four.
You went this one too.
That's eating.
And what's the answer to two?
I remember like what it looks like, but I don't remember exactly.
And what's the answer to two?
Did you get two engines? Oh, it's a two?
Oh.
I still don't know how to do song.
So it's two, two, ten.
Wait, could it could it also be?
Oh.
That's what was on the past. Could it also be? It also.
It's a great.
No, it's.
Then I knew, 7, 5, and then 11.
Is it? I don't know where. I was talking. to my-
Wait, I got
Like, for the last one. Was root.
Wait, that way, it would be the other way around.
Root three, whatever.
Yeah.
Yeah.
I would have thought it was.
Places where Y is.
We haven't discussed with your neighbor. Please do so.
So.
I'm trying to figure out. It's not right now.
Something.
Little thing. The philosopher.
It goes.
The average, like the two.
So number two. That's a good.
Eight really good. Yeah, I'll remember that for next. Yeah.
He's at five.
It's one day.
Wait, so it would be.
So we got.
So it can't, it's not the first.
What about David?
Five.
Not sure.
Alright. So.
Yeah, five, right.
Yeah, so. Oh, stop. Three. Wait, it's three. But you ever really? That's. But no, it isn't. Three. Not that I don't ask. But they were.
That's not happening.
No, no, I saw it.
Yeah.
Yeah. Alright, it's 120. It's 120.
Yeah. Or. What's there?
Try to only one, yeah.
I know, like.
Are we ready?
Yeah.
Ready or not? Let's go. Sketch of the function f of x equals tangent of x. First of all, let's put in the, what are they called? Vertical asymptotes. The first positive one is at 5/2. Why did I have to unfreeze it? Okay, so picky. Thank you for letting me know. Okay, so, and we also have this one over here in between, looks like. Did you bring your pocket tangent? I don't think we talked about it last time, did we? Your pocket tangent? I don't think the pocket tangent exists. I think it's a full body tangent. Bam, right? It's this one, isn't it? It's this. Oh, that's nice. Oh, that works. Okay. Mini. Or this. Bam. Yes. Yeah, so it's, oh, how many points did I want? 3. The first one's at 0, 0. That's the easiest one. The next one is at 5/4, comma 1. And can you visualize that on the unit circle? 5/4, the tangent is 1. How do you visualize that?
What's the pi?
Sine over cosine.
I know.
Yeah, Connor.
Well, it's like the 45-degree angle, so it's at, root 2 over 2 over 2.
There we go. Okay. How else do we visualize that from the unit circle? Yeah, Max.
I was thinking like, well, kind of the same thing.
Okay. Okay. Another way to think about it? Yeah, Simran. Okay. Oh, nice. Well, we're still doing tangent. We're still doing the tangent. Yeah, I feel like you're going ahead. Well, we're still doing the graph. So, but my question is, how do we remember that tangent of pi over 4 is equal to 1? So it's been brought up that the x and y are equal to each other, sine and cosine are equal to each other. There was one other way to think about tangent. Does anyone remember the other way? Slope. Right, could you imagine that slope of the terminal side being 1 right there at pi over 4? Because y over x, so it's a slope right there. And of course, negative pi over 4 is also negative 1. Is this the full tangent? There's more. There's this. And there's this.
It repeats.
It repeats because it is.
Is this a repeating?
What's it called? Periodic. So this is pi. This is 3 pi over 2 right here. Dun, 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 dun. Do you know what each one of these pieces of tangent is called? Do you know what the pieces are called?
Yeah.
Each one is one period. Do you remember from rational functions what each one of these is called? No, you also find them on trees. Or branch. Each one of these is a branch of the tangent.
Mandarins, that was a great guess.
Tangerine? Tangent, what was it?
My table mates actually just said tangerine.
Oh, that's cute. I like that. It's a tangerine. Oh, I'm not gonna think about that in the future. Okay, and we can see here that the period for tangent is pi. Are we good with that?
Yes.
Like on that main branch, we have negative pi over 2 to pi over 2. That's a full pi right there. Okay, sine of x equals negative 1/2. I would like to hear from the one and only Shiv about this.
Negative 1/2, that would be at 7 pi over 6 and 11 pi over 6.
And 11 pi over 6. Are we good with this? Any questions? Good. But maybe one of your questions is degrees, radians, same thing. Yeah, how did you get these answers?
Because sine is the line for the way. A of plus. The bottom two have negative signs. So.
Okay. So you had a unit circle. Was the unit circle in your brain, or did you actually look at one? Okay, nice. So you were like, okay, it's the y value that is we're looking for negative 1/2, and then it's this angle and this angle. Is that kind of the way you guys did this?
Yeah.
Did anyone just do that from their brain?
That's how we.
I do urge you to get there. Like, don't depend on. I need a unit circle in front of me. If you can, just write. You need that unit circle up in your brain first. Any other questions about this? Yes. Good question. Is it appropriate to put both values? Is that okay?
I would say so.
So we don't in math. Listen up. We don't only want correct. We want complete. Correct and complete. So since there are these two spots, I want both of them. But there needs to be one more question. We'll get to that one. The question about this though is how about the rest? Aren't there more solutions? So number 2, aren't there more?
Yes.
Would you please discuss with your neighbor where are all the other ones?
A billion times. Yeah. Bye.
Oh, do you think?
Okay.
You are.
So Augie, do you have a question or answer?
Oh, I have an answer.
Okay. I'd like to hear from Augie in 5 seconds. 5, 3, 2, 1. Okay, so Augie, you say you have some more.
So like literally all of the solutions that would like result in adding plus 12 pi/6 times infinity or negative infinity.
Ah, okay. So when am I going to do this 7 pi/6?
You could change it to okay.
Yeah, we need to add something to this, don't we?
Yeah.
Specifically, we're going to add just 2 pi, or 2 pi, or sorry, 4 pi. Is it 2 pi? Okay, and this is what we talked about when you weren't here, but yeah, k and k, of course. Would you please write what we wrote about k last time?
Number.
There's a little three character representation of k. It starts with k. The next symbol is
Oh, the epsilon.
it's an epsilon, but we read this as belong or element. K is an element of, and then the symbol we write after that is Z with a double staff Z, and Z stands for integers. So that includes like negative numbers where we go back. We take this and we go back 2 pi, back another 2 pi, back another 2 pi. Right, that's just multiples, right? I made it animated. Right, so that's what that first one is talking about. Oh, did I just do it forward? I think I was just doing positive, wasn't I? Let me do make an arrow first of all. Didn't work. Okay, so this will be back on it. There we go. Back, bam, right? So those are just all minus 2 pi's, aren't they? Multiples of 2 pi. Not usually. And of course, at 11 pi/6, we're going to do the same thing. I know, it's amazing. So many colors. And k is an element of Z. Epsilon means it's part of a big group. You have anything from the group. Equals is specifically a number. In other classes, sometimes people say kes for this. I don't normally do that, but I'm sure you understand it. But. And also in this class, if you use k here, then let's just assume that it's k as an element of the integer, so you don't have to write the rest. In this class only, are we good with that?
I feel like in every class.
So if you go to another class, they may expect you to do this, but in this class, you may leave this off. If you just put a k there, I'll assume you're talking about integers. So you don't have to write that every time, because it's going to become a thing. Okay, so we have that. And Shiv, thank you for your help with that. Kayla, can I get your help with number 3? Did you get this? Say it one more time. Pi/3 and 4 pi/3. And how did you get these? Okay. So you're either talking about a pi/6. Say that again. Okay. So you knew that the y value has to be bigger. Are we good with that? And then that came back down into 4 pi/3. Did anyone think about it differently? Yes. Yeah. Yeah, I'm thinking slope really helps here too. Right, square root of 3. There's too much talking, guys. Max. Yeah, it's awesome. Max, face it front, please. It's okay. Square root of 3 is definitely greater than 1, isn't it? And we know that at pi/4, the slope is 1, right? Tangent of pi/4 is 1. So it makes sense when you see that square root of 3, it's either going to be pi/6 or 2 pi/3, isn't it? And since we're looking for square root of 3, that's bigger than 1, so that definitely points to right there at that pi/3. And also that we get from down here. Of course, given what we just talked about, what should we do with these? Well, go ahead and discuss with neighbor. What should we do to adjust to make sure that we not only have the two regular ones, but all of them?
Same thing. I have some plus two. Yeah.
Okay, so should we just add 2 pi k to both? Are we okay with that? Ah, would that be enough? Wait a minute. So you're saying we could go here, use this one, and then just add pi? And then add another pi? Does that make sense?
Yes.
Yeah, so this was a little bit different where because, and what's special about pi for this problem? It's a period of tangent. Yeah, so those values are going to come out in every pi away. So we don't have to do all of this, although this is true. We could just use one of them and say pi over 3 plus pi k. And that is what I would expect. Even though the other one is correct, this is more efficient. And that's what I'm looking for.
Efficiency is key.
It is key.
So you wanted to do pi for sine and pi for sin?
Very nicely summarized. How about cosine? Also 2 pi. Yeah, period is 2 pi. Yeah, just use a period of whatever function you're dealing with. Hey, do you all have your pocket tangents?
Oh, I do.
Can I see it? Can I see your pocket tangent? I just
do.
want to see. I just want to see a room full of pocket tangents. Some of you got the big ones, some of you got the little ones. Okay. Yeah, you're right. Or you need a big pocket. Yeah.
No, that'd be fun.
Okay, so today. So notes are not coming from the packet. You just need a blank sheet of paper. And algebraically, it seems like we solve this with a method called analytically. Does that make sense that that's the method we use to solve this equation?
Yeah. Like,
Or you analyze, yeah, detectively. Yeah, a detective work. Yeah, we did a little bit of that, knowing our unit circle. We put up the pieces together. But algebraically, do you know how we would solve for x? Could I divide both sides by sine? Would that make sense? That makes no sense at all. And what we need is an inverse of sine.
Sine negative.
So today we're going to be building the inverse functions for sine, cosine, and tangent. Okay, so yes.
Feel like
Oh.
so much for writing.
Oh, thanks, Max. No, thank you. Thank you. This is called a thank you battle. We'll see who wins. Oh, you can't join the thank you battle. Inverse of trig functions.
Thank you.
You could get hurt in a thank you battle, so be careful. Yeah, it gets pretty extreme. Yeah. So let's start with y equals sine of x. I think you know what this looks like. This function. And I'm taking up the left side specifically because I'm also going to write on the right side. So make sure you just draw a little sine wave on the left. I want 1 period right here, and I want 1 period right here. So the question I have for you now is, does sine have an inverse function?
It totally does.
But there's a problem. There's a problem because this function,
Yeah.
it fails the horizontal line test like in the worst way possible, don't you think? Like if a parabola fails it, it fails it infinitely many. It's like, yeah, it just fails the horizontal line test, which means the function is not one. It's not 1-to-1.
Vertical line test or that's something like that.
Yeah, vertical line test means it is a function. It's a function.
Now maybe we could use.
Passes a vertical and horizontal line test. Yeah, it has to pass both. So what we're going to do is we're going to restrict the domain such that it does pass the horizontal line test. So there are different options. Like we could just make it from here. Does that make sense? That Well, let me put this in that
Oh, that makes sense.
digitally. If I just restrict the domain to this little region right here, wouldn't it be 1-to-1 and forget all the rest?
Yes.
They would be 1-to-1 decimal. But we're not going to restrict it there. We need a restriction such that all math agrees on this range and it's not just arbitrary. So what we want to do is include 0 in our restriction. And if we have to choose between positive and negative, always choose positive. So think about what are you going to restrict here for a sign to make it 1-to-1? You're welcome to discuss with a neighbor. I don't want an answer yet. Just discuss. What do you?
It's not. I'm the almost there. No. My neighbor.
Yeah. No, it's not so hard. No, 0 hard. Oh, you go from there. Windows. I think that we should already.
Do we agree with this? Is this okay? I've done a terrible job. I should be restricting from
-5.
-pi/2 to pi/2. Are we good with that?
Wait, why is not? I live
Or I guess it could be here. It could be here, but I want to include 0. That's first order business. I'd like to include 0. So yeah, we're gonna restrict from here. Is that what you did? You restricted right there?
Yeah.
What do you think, Nathan? Does that make sense? So now it's 1-to-1. We kept all the values, all the y values. So they're still there and we restricted them. So in the x we have, I think you said -pi/2, and this one is pi/2. So this is 1, this is -1. Would you, on this graph over here, please draw the inverse of sine? Simran, did you have a question?
Invertible is the was that does that be 1-to-1 or pass level?
Those are the kind of the same things. We know it's 1-to-1 if it passes the horizontal line test. Okay. Great question.
It's your invertible function.
Yes.
I think we're making a pi/2 from a 1. So 1.
Yeah. See with your neighbor. Do they put the inverse together?
Yeah. Wait, so what should be like? It's 1 pi/2 and then -1.
-1. Wait.
Switch the x and y. coordinates. So it's like 1 pi/2 -1. Yes.
Yeah.
So on the x-axis, what are we marking?
1 and negative.
Does that make sense? -1 and 1 on the x-axis now? And on the y-axis, it's now going to be pi/2 and pi/2. Yes. And just to make sure it's set for success, this point here that used to be pi/2 comma 1 is now at 1 pi/2. Is this what you have already?
Yes.
And then 0, 0, and then this kind of falls into place. And are we okay with this?
No, it's not right.
What I've done is I've accidentally copied this, but I want you to imagine, Joseph, with me here. I want you to imagine the sine wave going up the y-axis. Does that make sense? The sine wave going up the y-axis. So what was wrong about this? What's the concavity was off. So we want to do this. Is that like to start going up the y-axis? Just want a little piece of that sine wave that would be going up the y-axis. We're imagining the sine wave continuing up here. Right, so it's not that it's changed, it's just now with respect to y. Yes, oh, that's nice. Yes, right. That's by definitely not by that. That's one property of nice inverse. Yes, reflected in the line y equals x. Okay, this function does have a name. Do you know what it's called? One name is arcsine of x. The other one that I'm going to be using mostly is sine inverse of x. Have you seen that -1 before? We've seen that in context of f inverse. So I'll put an important note up here. Note, sine inverse of x does not equal 1 over sine of x. Right? So it's definitely not cosecant. It's just the inverse of sine. Completely different. Cosecant, by definition, is the reciprocal of sine. It's not switching the x's and y's. It's just flipping the adjacent, the opposite of the hypotenuse. Common misconception. So don't let that be you. Don't fall into the trap.
Don't do it.
It's hypotenuse. Yeah, for cosecant is hypotenuse opposite. What's that? Yes. Yes. Go ahead and write the domain and range.
It's also like that.
Okay, the chit chat needs to stop forever. Okay. What should we do next? We just done sine inverse. Let's build the cosine inverse. Yeah. Not today. Today we're doing sine, cosine. Tangent. Yeah. Oh, no, we haven't. Yeah. That's similar.
When I wasn't signing up for thing, I'm just confused.
I'll talk about that. But what happens if you switch x and y's? That's how. So maybe you're gonna start with y equals cosine of x. Is y cosine of x? Is this invertible?
No, yeah.
Is it 1-to-1?
Not yet.
Probably restrict the domain. Yeah, probably necessary. Make sure that you and your people around you are restricting the same, and then we'll verify we're doing the same thing. Still negative pi over 2 to pi over 2, is that right? I don't know. I would shift it on the side. Might be. I would use pi. Did you discuss with your neighbor like what you're restricting? And remember, it needs to include 0. And when you're choosing between positive and negative, choose positive. Sure.
Yeah.
Sure. Okay, so I heard from 0 to pi over 2. Is that okay?
And here to pi.
Well, 0 to pi over 2 is still 1-to-1, isn't it? 0 to pi. Yeah, we keep all the y values that way. Yeah. Oops. Let me put that back.
That's just one.
Yeah, so if I go from 0 to 2 pi, is that okay?
Yes.
0 to 2 pi? The function still fails the horizontal line test, so we just need to erase just enough to make sure that we keep all the y values. So this, and I heard to pi, so like this is what we did.
Oh my gosh, that's.
Yeah, that's what we look for. And we need to standardize this so all mathematicians are doing the same thing. So this is what we use. Go ahead and build the inverse of this, graph it, and write in notation what it is.
Work on this.
I like that attitude.
Not let's work on this, let's get it done.
Oh,
'Cause then
Oh.
it implies that we're not gonna try fraction.
that's a good one, Max. Thank you.
Beautifully said. Well, so what is this? Yes. Yeah. See this? Yeah. Hey, yo. Okay. Okay. I'm sorry, I still have to be. Are we? Wait, what is?
Yes.
So on the x-axis, we're marking -1 and 1. On the y-axis, 0 is already there, so we're just going up to pi. I want 3 points. I need to call someone for the 3 points I need to put on here in just a minute. So make sure you have the 3 points I'm looking for. If you're not sure what the 3 points are, maybe click here and get 3 important points and then transfer them.
What do you get for 3 pointer?
Like 3 points, oh, 0 and 1. And I over 2. Oh, it's for the end. I'm not that.
I got the 3 points for that day.
It's a whole.
Wait,
Okay,
wait.
I'd like to hear from Leah. Can you help me with this? I just want the 3 points I need to put here.
1, 0.
How do you get that?
Like the original graph, like the 0.0, so then you switch the x and the y.
Nice. Okay. Because these functions are inverses, and that's exactly what it is. Give me the other ones, please.
Pi over 2.
Okay.
And then we got -1,
Are we good with this? Very nicely done. Thank you. Now, should I just make a line?
No, it's a.
Yeah, yeah. It's definitely what kind of a curve? Yeah, a piece of a sinusoid, right? It's specifically a cosine. Can you imagine the cosine going up the y-axis? Looks like a what? That one doesn't have. Oh, it does. That's true.
This guy.
There we go. And if you want to visualize the rest, right? Here's a cosine wave going up the y-axis, right? That's that actually. Thank you. Domain, you're right in domain and range, and after you finish that, of course, you're going to work on. We did sine, cosine, tangent. Homework, you guys are so funny. Not yet. I know you love homework. Gotta wait. Right, Max?
Wait till we're.
All in good time. What?
There's more work to be done.
Yes.
Better keep on going.
Yeah.
I don't know.
Thank you, Emma. Thank you. Oh, I see. Okay. Well, the scratch paper is up top. I think you might have taken.
Oh my god.
Thank you. I wish I had that. How come this is I wanna get. Wait, I was talking.
I love
Yeah,
that
but you remember.
domain.
I was talking on one of those things, like third grade.
Yeah. Hello. Oh, my God.
Oh my gosh.
Wait, if we all stop talking, but not keep talking.
What do you say?
I never thought about that. That's a good idea. Okay, did you get tangent?
Oh.
Did you get tangent?
Domain.
Wait, this one's saying the.
Wait,
Yeah.
what is it called, arc cosine?
Oh, thank you. They have a name. Yes, either arc cosine or cosine inverse. Yeah. If you're given a choice. So once we define these, you don't think about that anymore. So is tangent 1-to-1?
Yes. If you I would say so.
Yeah, it is 1-to-1.
If you have one, I don't think it's 1-to-1.
If you have.
So should we restrict from 0 to pi? Would that work?
No.
Yeah.
Wait, yeah, but.
0 to pi works, but it's weird, isn't it? It's ugly. We don't want to include that. Undefined, yeah.
Wait.
What area?
You mean to pi over 2?
Negative pi over 2 to pi.
That's what we're gonna do. That's what we're doing. For sure. Yes, all right.
I'll do like 0 to pi over 2 and then give me into that.
Yeah, you're right. We can't even go from 0 to pi.
Is that?
Yeah, it's just too weird. So we keep that middle one.
Yeah.
Oh, and I want 3 points on the inverse, please. 3 points on the inverse.
Oh.
Oh, shit.
Like most times you like okay, like most dining halls, I was just really like videos. I like I want to be able to go into a weekend in a city. Oh no, but so no, it is. Every city has a high history.
Okay, folks. So what happens to those vertical asymptotes? What happened to the vertical asymptotes? They became horizontal, yes. So pi over 2 up there and negative pi over 2 over here. I want the 3 points. Did you get the 3 points on this inverse of tangent? I'd like to hear from the one and only Max. Can you tell us what the 3 points are?
Okay. 0, 0.
Okay.
As to be expected.
Yes.
And then I got 1 pi over 2.
1 pi over 2, like up on the horizontal asymptote?
Is it not? Pi over 4.
Oh, I figured that's what you meant. Okay, so like right there.
Yeah.
Okay.
It's because it's half.
It's half.
And then it's gonna be negative. And then negative pi over negative 1.
So like this?
Yeah.
So it's a nice line. You get
Yeah.
just cutting right through those horizontal asymptotes.
Pretty much.
Yeah, exactly.
Are we allowed to go for
Well, it's the same as this.
Oh yeah, it's an asymptote.
So this doesn't cross over the vertical asymptote, so it will not.
I do.
Yes.
I mean, I like my food.
Okay. Correct. Well, remember when we restricted this? There are no arrows here. There are no arrows here. It's just a little piece of sine and cosine. Yeah. We definitely need that. Good question. Did you write the domain and range here already?
Yes.
Domain is from negative infinity to infinity, and the range negative pi over 2 to pi over 2 exclusive. Okay. Not yet. There's more to be done. Is a good question though. Okay. I want to take a look at this. I remember the sine wave comes from the unit circle, correct?
Yes.
I want to look at this and think back to unit circle. Which quadrants does this reference? Think about it. Don't call it up. Which quadrants does this reference? It's two quadrants. And when you have an idea, hold up those two numbers. Like if you use 4 and 5, you hold up 4 and 5. So which quadrants in the unit circle does this represent? Like which is that reference here? And take a look around you and just make sure that people around you are in agreement. So one is definitely true. The other quadrant is what we see is quadrant 3. We see is quadrant 3, but we're talking about 0 to negative pi over 2. Now think about the unit circle. Where is 0 to negative pi over 2? That's exactly quadrant 4, isn't it? 0 to negative pi over 2? So we see points here in quadrant 3, but this is referencing 0 to negative pi over 2 and 0 to pi over 2. That's quadrants 1 and 4. So this is some information we're going to include with our sine, that this is quadrants 1 and 4. And cosine inverse is quadrants. Is it 1 and 2? Is that true?
Yes. Yes.
Well, we're going from 0 to pi, that is 1 and 2. Right?
It's amazing.
So quadrants 1 and 2. For tangent inverse, we're talking about quadrants. You see? And if you look at it, it looks like quadrants 1 and 3, but it's still quadrant 4, isn't it?
4 and 1.
So quadrants 1 and 4.
So it's like sine.
It's the same as sine.
Wow. Isn't it crazy how that math is all
Cosines 1 and 2. So this is really nicely depicted in your packet. Right here, page 6. So, is this a good visual?
Yeah, I like that.
Yeah, I really like this. I want you to blink to click that into your brain. We got our sign right here. Our sign is a y value, so we just want the one of each. These two quadrants. Cosine is the x value, so tangent x and y. Okay, let's do some problems. Yes. You can just look at this. I know you want to do homework. We're not quite done yet. And there really is too much chatting. There's too much chatting. I appreciate the excitement. I know it's all about this, so I'm gonna keep going. We have to do some sample problems. Sample problems. So we're gonna go to page 16 in the packet. And Augie again has to just copy from here. And we've talked about the functions, but we haven't done problem. When you see this sine inverse of 1/2, you have to think, what does this mean? Now, normally the input for a sine is an angle, isn't it? Where the output is either x or y value, or a ratio. Yeah, Connor? It is like on the test? True, it's also exactly like, well, similar to the problem on the warm-up. This is when you see this number in the inverse, that's talking about the coordinate, and it's asking for the angle. Right? And it could be in either radians or degrees. The angle whose sine is 1/2. That's what it means. The thing is, since we're talking about inverses, we're restricted to a couple different quadrants. Specifically for sine, it's either 1 or 4, which is why this only has one answer, which is 5 or 6. Are we good with that, 5 or 6?
Oh my god. So
See?
I'm in the first chair of the math class.
Oh, wow.
I feel like I'm
Look at all these.
No, I wish I did that. Wait, no. I don't know what I Oh, yeah. It's 9.
So the sine inverse of 1, did you get it?
5/2.
5/2. And we can look at our graph, sine inverse of 1. Right, if I look at my graph, it's right here, sine inverse of 1. Do you see the answer there on the graph? Sine inverse of 1 is pi/2. Or just the angle of, sorry, get the question here. I'll get your question just so. Here, this is talking about the angle whose sine is equal to 1. And that is either pi/2, or we could say 90, but no other answers.
Wait, so for 9 to be, it would, there's technically, say that also
Well, we used quadrant 2, but we didn't take the quadrantal angle along. Yes.
What's the reason about doing plus k?
The reason is because of our domain, right? We only have restricted values. Well, we have the axis. Right, if it went up, then we could do plus k. We could get some more up there, but it's not. We just have one answer for all of these. By the way, for these quadrants, what I refer to, I don't talk about domain and range. I just say that sine inverse lives in quadrants 1 and 4. I say cosine inverse lives in quadrants 1 and 2, so you don't have to worry about which word is appropriate. Yeah, perhaps. Sine inverse of 3/2, is 5/3. This is a tricky one. And many of you, I think most of you will get this wrong, but try it and check with your neighbor. Yeah, sine inverse of -1/2.
Yeah. Why did they ask me why there's a good domain? Oh, okay. No, you're right. It's 11 pi/6. I can have an answer. It is 11 pi/6.
Yeah, 11 pi. They said most of us are gonna get a response.
So this one. Hey, don't say anything yet. This is a common answer. I'd like you to tell me why this is wrong.
Because it's not in the
Well, It's in quadrant 4.
No, it's not in the domain of the graph.
Yeah, if we take a look at the graph,
More than one. Wait,
if we take a look at the graph, it's sine of negative 1/2, right? Right here.
It doesn't make it down, it doesn't go up to 11 pi over 6. So you don't have that.
it's greater than one.
Negative pi.
Yeah, the answer we have is negative pi over 6 is what we're looking for. And I'll explain that again because I know that it's weird.
So if we go past pi over 6.
So relating this to here, oh my goodness. Page 6. One moment, please. Yeah, page 6. So we wanted to get here, didn't we? But we can't go this way to get there. Right, it goes outside that gray area. What do you think, Nia? Does that make sense? I can't go that way, so I have to go from 0 to get there. It's got to be back into that. We have to stay in that place where it's is. Yes. Yes. Yes, exactly. Very nice. Yes, we found the right place, but 11 pi over 6 gets us the other one. Now someone in my other class very astutely said, can we just pull that negative out? Can we just pull that negative out? Can we do this? Is that okay? Or is that just a coincidence? Yeah, what kind of function could you do that for? For odd functions. Is sine inverse an odd function?
Yeah. Yeah.
What did you discuss with your neighbor? Is sine inverse odd?
And so.
No, I think.
Okay. Take a look.
On function, you can take it out. Even function.
What do you think? Is it odd? How do you know? It's reflected over the origin. Look at it. It's reflected over origin, isn't it? Whereas even functions are reflected over the y-axis. So cosine inverse, is this even? Is it odd?
Even.
I think cosine itself is even, isn't it? We have that nice reflection over the y-axis. But cosine,
No.
not even, not odd. Don't try to do anything crazy with it. So sine inverse, yes, you can pull the negative out if you want. And so we have that negative, and then this is just pi over 6, if you want to do it that way.
Do they have to use that to like you on that?
I'm not telling you for fun. I'm the same answer. It's the same answer. It's negative pi over 6. Yes, Simon? Even you can just get rid of it, but none of these are even functions. So sine inverse of -1. Is there an answer to that? Sine inverse of -1?
Yeah. Negative.
Yeah, negative pi over 2.
Wait.
Isn't it?
No.
I swear.
No.
Good question. We also say negative pi over 2? 3 pi over 2? I don't think this makes it up to it. It doesn't make it up to it. Oh, this is cosine, excuse me. No, it's a quadrant.
We can, but yeah.
So this inverse sign doesn't go all the way up to that 3 pi over 2. We have to do the other angle, negative pi over 2. The next set of problems is cosine. Go ahead and do those top 6.
Okay. You two tiles.
Be careful with the negatives.
I'm thinking. Oh, wait, I can. I think. Well, you still have those like when they on. Oh, I didn't. It's all right. Probably just about them.
I'll call on some people in about 10 seconds.
Like.
Okay. Cosine inverse of 1/2. Chloe, what'd you get? Are we good with pi over 3? Thank you, Chloe. Cosine inverse of 1. Lee, what'd you get? Is that right?
I got 0.
Nice.
Yeah.
L, what'd you get for cosine inverse of root 3 over 2? Yes, are we good? Any questions? Oh, okay. Oh, is it pi, not pi over 2?
Six.
I don't.
Let's see, we're talking about the angle whose cosine is root 3 over 2. Is that pi over 2?
No,
Pi over 6, is it?
yeah.
Oh, you said pi over 6? Oh, I misread it. Okay. Sorry about that. Yes? Okay. Cosine inverse of -1/2. Leah, what do you think? Oh. Well, Leah does sound like Nia, but yes, what you got? What is it?
Wait, sorry, that's your 5.
Nia, do you agree with that? Okay. Are we good?
Yes.
Thank you. Nia, how about cosine inverse of -1/2? -1. Get that. Hi. Yes? Is that right? Thanks. And cosine inverse of -3 over 2? Pi over 6? Yeah, all of our answers have to be between 0 and pi. Let's do one more type of problem. Yes.
This is right there.
Yeah. There's a big problem here. We haven't done this. What's that? And the -3/4, is that even on here?
Wait. It's over. Yeah.
Yeah.
That would make sense with this.
No, that doesn't make sense.
It could. Let me break this down. When we talk about cosine inverse, that is referencing
The angle.
the angle
That gives you that.
whose cosine is -3/4. Now, is this asking us to find that angle?
No.
No,
Or sinus.
Asking us to find the sine of that angle. So what I'm going to do is I'm going to draw an angle. But where is this angle going to be? Starts with the origin. Well, cosine inverse lives in quadrants 1 and 2. So I'm going to should I just go at quadrant 1? Everything's positive. It's negative. So I'm going to put an angle right here. And I'm going to make my triangle by going directly to the x-axis. What do I know about this triangle? Is it 3, 4, 5?
No.
I know the adjacent is I'm gonna say -3, and the hypotenuse is 4, right? So this is the angle that we're talking about, yes. It can't be that for cosine inverse. Cosine inverse lives in quadrants 1 and 2. Yeah. Okay, so this is 3, 4, 5 triangle, isn't it? No? No, yeah, that doesn't work. Do we know that other side? So remember, we use Pythagorean theorem. So we have -3 squared plus x squared equals 4 squared, and we get that x equals square root of 5. Is that right? Plus, is it plus root 5 or minus root 5? Oh, is it 7? I don't know, 16 minus 9. It's 7. It's 7. Okay. Positive root 7? How do you know it's positive?
Wow.
It's going up.
All students take that.
Oh, no. So the answer to this question?
I just say.
Yeah, we have sine, so root 7 over 4. Yeah, Oliver, you had a question? Or you're thinking?
No, I don't know why I have that.
Okay. Yeah, Simran?
That-
Because I see that the adjacent is -3, the hypotenuse is 4. It's the angle whose cosine is -3 over 4.
But it's 7, except for the 4 there.
No, it's the sine of the angle. If you want to hang out a little bit afterwards, you can, but our time is done. That was a ton of stuff today. Have a great weekend, everyone. Homework is from online, so it'll be available a little bit later. It's Pearson homework this time. Thank you for asking.
Partying it up with Jenna. Jenna, not all, but Jenna is.